Hey, hey.
Coming right up, I want to present a man that maybe needs no presentation, but let's do it anyway.
Okay, here I am.
Misko.
Here I am. No, no, it's not.
Okay,
Oh, you didn't want to.
Shai, what are you talking about? What sort of server first meta framework are you talking about?
I actually don't have a clue about server. That's why I'm here. I'm here to learn from the smart people in this meetup. And I just wanted to say one thing before we start Mishko's lecture, that I think the first time
The first rule of talking about
about Mishko is never talk about Mishko. No, but that's that's me with the beard. I'm Shai Resnick, one of the team here in JavaScript Israel. And what I wanted to say is that the first time I ever interviewed someone in English in a meetup or a conference was I think in 2014. We did an Angular Israel event. We called it. We even stole the name ngconf, and we call it ngconf Israel. And Mishko was in a remote session just like now, but in a room full of people before COVID and stuff. And nobody knew who will interview him. And everybody said, Shai, you will interview him. And I was scared because I never talked to Mishko. He was like a big celebrity. Back then Angular was the framework, and Mishko was the father of Angular. So I interviewed him, and here he is. Here he is. Nice. Hello, Mishko. We're closing the circle, as we like to say. The husband of the house gone crazy. This is how we say in Israel. The Baal Habayit ishtagea. So welcome, and that's it. I will stop digging now and have fun in the lecture.
Thanks, Shai. Sorry, I muted myself and I turned off the video and I forgot to return it back on. And also, we had kind of a huddle before the meetup, and I saw everybody. Shai was there. I didn't recognize you, man. With your beard.
No, I wasn't there. I wasn't in the huddle.
Oh, you wasn't?
That's okay. No.
It's the other dude with the beard. They work together, so it's like they're almost the same person.
Almost.
Okay.
Almost.
Well, I'm really impressed with your beard.
Thank you.
Got me fooled.
Okay.
Got me
Enjoy.
Fooled.
Thank you very much.
So let's see. Let me try to share my screen here. And okay, sharing screen. Let me know when it's on and I can get going. All right. So where do we start? So we start, I think, at that. Yes. So I have Angular. One of the kind of the thing that happened was Angular. And now I've kind of moved on, and I'm trying to build a new thing called Qwik. And you might ask yourself, well, why yet another framework? Don't we have lots and lots of existing frameworks? And I think the answer to that is, if you look at all of the existing frameworks out there, they're essentially the same. The only difference between them is that you're kind of debating about the DX. Do you like you have your templates directly inside of your source code? Well, then probably JSX-like framework is your thing. Do you like your templates to be separate? Well, then maybe Angular or Svelte is your thing. And so the only thing that you're really choosing between these different frameworks is the developer experience. Not to say the developer experience is not important. It is very, very important. But once you choose your developer experience, all these frameworks are pretty much the same. Some of them are a little better, a little faster, or the large apps can be broken down. The slope for the applications are a little better, but overall it's kind of all in the same category. And the reason for that is because all of these frameworks kind of have blinders on. What I mean by that is that they say my job of the framework is to render on the client. So if you look at Angular, React, Svelte, Vue, what other framework, what other popular frameworks are out there, they're all basically say, hey, my concern is rendering on the client, and they completely ignore the server-side rendering portion of it, or the bundling portion of it, or all the other parts that kind of go with a full application. They're just basically say like, I just care about my little box over here, and that's all I care about. And then somebody else can solve the other bits and pieces. And there are lots of frameworks that we call meta frameworks that go on top of it. For example, NextJS and so on. And while these frameworks solve a lot of things, they don't actually solve the core problem. And the core problem being that the framework itself has a lot to say about the impact of how the application is being built. And so if the framework itself doesn't kind of cooperate with the outside of the framework, the meta framework, you'll get an suboptimal choice. So the way the Qwik is different is that instead of Qwik focusing purely on just the rendering portion of the page, Qwik actually focuses on the end-to-end experience. And Qwik isn't just about client, it's about server and the client, and the distinctions between the server and the client, like what can run on the server, what can only run on the client, how do I transfer state from the server to the client, and basically all of the parts that go with it, so that you kind of have a holistic experience when developing your application, and you aren't pretending that you are client only and then figuring out some kludgy way of getting it server-side rendering to kind of happen. You know, as we were pointing out earlier, bots might not be able to see you, so you need a server-side rendered output, but how do you make it in a way that it's kind of seamlessly transitioning? Okay, so let me transition over to giving some demos. I think a demo is worth 1,000, or a picture is worth 1,000 words. So let's do pictures. I don't know if the font, hopefully the font is big enough to kind of see this. So what is this? This is a to-do application, and I can refresh it, and that in itself is not that interesting. I'm sure you've seen the to-do application before. I think what is interesting is if you look at the network tab, you will see that there's no JavaScript actually downloaded in here. There's no JavaScript that's actually going, and if you were to do view page source, you would basically see all of the HTML inline directly in here. And so because we have HTML that comes in and shows up, this is perfectly fine to run on, this is essentially server-side rendering, and the bots and the search engines and SEOs, everything will just work beautifully out of the box because it's HTML that came in. Now, if you look at the source, there is actually a little kind of code on here. Right now we're running in a dev mode, so this is non-minified, but this script tag that you see over here, it represents about approximately 1 kilobyte amount of code. And nothing in this script tag is actually application specific. It's actually just the kind of the thing that gets the application going. And the beautiful part here is it doesn't matter how big or small your application is, your initial script tag will always be about 1 kilobyte. And if you look at the performance of it, this initial script tag takes on the order of, depending on whether you're on a mobile or a desktop, somewhere between 1 to 10 milliseconds to execute. So this is extremely cheap, like a piece of code to execute. And the reason we inline it is because it's so tiny, we don't even want to bother the browser making another HTTP request to kind of fetch the whole thing. So it's all inline, it's quick. Anyways, so the result is that there's no JavaScript present whatsoever. But if you don't have JavaScript present, you might say like, well, that's great, but like that means that my application is not interactive, right? Like the whole point of a JavaScript is to build interactive experiences that you can modify and live. And so you would think that this is kind of a static page, but instead this actually comes to life. So let me show you how that works. So I'm going to start typing, and I want you to pay attention to what happens in the network tab. Oops, I have to flip it over to JS. So let me try this again. So we're in a JS mode. We're showing you there's no JavaScript present whatsoever. And when I start typing new item, you can see that the code downloaded. So here's a kind of a first big difference between the way existing apps work and the way Qwik work, or the existing frameworks work and the way Qwik works. Existing applications or existing frameworks want to have some kind of a main method, right? Where some kind of bootstrap where you have to enter and get the application running to kind of get everything set up. And this is the kind of a point that we're talking about in Qwik, is that Qwik is resumable. So if you look at the URL, right, the first file that we downloaded is the header on render input on key up, right? Because that's what happened when I started entering the keys. Now, if I refresh this, and perhaps maybe I'll delete an item, notice the entry point is a different entry point. So now it's item on render button on click. Maybe if I go and click on this thing, yet it's another one. If I go and say clear completed, it's yet another entry point. So the kind of code that we download and how the application gets bootstrapped really depends on how you as a user interacts, right? And this is a very stark contrast to the way existing frameworks work, because existing frameworks simply assume that there's always one entry point to your system. And so that's kind of a big difference. So let me go back to entering the code. So I'm going to type in new item, and I've only downloaded the code for processing the key up, and I've downloaded the code for re-rendering this header location over here. And then if I go and I hit enter, notice even more code downloads. And if I go and maybe hit delete, more code downloads. And as I interact with the application, as I click on different parts of the app, more and more more of the application that I have keeps downloading, right? And so this is, again, in a very stark contrast to the way existing frameworks works. And existing frameworks kind of front load everything to the beginning. And then as you interact with the page, nothing more has to get downloaded. Here, we're kind of reversing this, right? At the beginning, you just end up with a pure HTML. And as you interact with the page, more and more JavaScript gets downloaded. So now, how does this magic kind of work? So let's kind of look at it more in depth. So here's the HTML that the server showed up. And one of the things you're going to notice is there's extra information in here. Things like QObject, QHost. Let me go to the input box right here. And you can see that this input box has an on key up. What the script tag that I showed you earlier, what its job is to set up a global listener for any events that come, because events in browsers bubble up. This onScript tag can set up a global listener in the root of the system, right? And so what is happening here is that it says, if you push a key and you have a key up event, the key up event bubbles up, which then ends up inside of the script tag. And the script tag then looks at this location over here, and this URL tells the system where the code should be downloaded. Now, this URL is pretty long because we are in a development mode. In production mode, the URL will be much shorter and will be obfuscated. And so this basically says, go and download the header on render input on key up file. And inside of it, you will find a exported symbol called header on render input on key up. So let's try that. If I enter a key, if I go to the network tab, this is the piece of code. And you can see that, sure enough, this file contains a piece of code that says what's being exported. And this is essentially the handler of the function. Now, what's unique about this piece of code is that it can resume. In other words, this is the first piece of code that the system actually runs, this function, right? There isn't any sort of preamble, right? Like existing frameworks, you can't just run a click listener. You have to boot them up. You have to, what we call, hydrate them on the client. There's huge amount of code has to execute before the system is ready to say, okay, now I'm ready for your inputs, right? And the reason why this is hard is because when you have an input, you have something like, for example, you have a state, and you're going to update the text of the state. So, if the key you entered is entered, then go and push a new item into the props and so on. And you can't just do that on the regular system, right? You have to wake up the system and be like, and run the hydration and figure out where is state. What does it even mean to have state? Where are the props coming from? Where is the event? What do I write to? Who do I update when something changes, right? So there's existing information the framework needs to have before it can go and execute the function. And what's unique about Qwik is that we flipped this around, and we basically said, no, when you go and start typing, this is literally the piece of code that starts executing. And all of the magical parts is hiding behind this function called use lexical scope. So let me show you why this is magical. So let's open up this component. And this component is going to be components, header, I think this is the header. And here is our input right here. And what you see here is, this is the function we're talking about right here. And this function is simply takes the input value, right, from the event, and it writes it into the state.text. Now, the first thing we have to do is, this is a closure. And closures, you can't really get a hold of the closure, right? So you have to do some magic, right? Because what we want to do is we want to download just the closure, not the existing state. So we have a piece of code called the optimizer. And what the optimizer does is it looks through your source code and it extracts your closure. So it finds this particular piece, and then it basically gives it a variable, and it does export foo equals, and pulls the code out like this. Oops. Now, notice something strange happening here. Once you pull the closure out, it doesn't know what state is, right? This state was important because it came from a store. And the state was important because this is where we keep the text, and this is how we render the input so that we can update the text. And so if all you do is pull the code out, which was a closure, which was relying on the fact that it was lexically scoped, and you just put it into a top level so that it can be lazy loaded, you kind of broke the code. Like, this does not work for your application. And so the magic of Qwik is to be able to do this trick and to continue to be able to execution, right? And so the way that Qwik does this is it says const state and props equals use lexical scope. So it calls a special function to restore these two values that you can see over here, and then the code can run as before. So obviously, this is kind of only pseudocode, so I'm going to undo all of this thing and put the application back it was in its original state. And what you can see is that this is where the Qwik lexical scope got downloaded right here, right? This is the magical bit that pulled it all together. And this is the bit that restored the props and the state. And so now you might be thinking, well, how does the system know how to do that? So let's go back to here, and we can see that with this, there are some additional information in what we affectionately call the QRL. And here there's information about saying like, hey, this function requires two additional things: a reference to something called 0 and 1. For complicated set of reasons, which I don't want to get into, this basically points to these objects, which in turn point to the objects in here. So here it says 6 and 7. So the sixth object in here would be 0, 1, 2, 3, 4, 5, 6. No, that doesn't seem right. Okay, I'm not going to go through this, but the point is this information here points to our serialized state. So when the server ran, when the application ran on the server, the state of the whole application got serialized. And when we go and start typing, this function right here can restore the state of the application. And this is why we say that Qwik is resumable, because Qwik continues running where the server left off, right? Like the way normal frameworks work is they because it's an afterthought, right? Because server-side rendering is really an afterthought in existing frameworks. What happens is that the framework runs in a server. It builds up information about the hierarchy of components and which component talks to what, and all the meta information the framework needs, and then generates HTML. But the HTML doesn't contain anything about the structure of the components, and so all that information that the server collected is essentially thrown away. And then the HTML comes to the client, and the problem is that HTML has insufficient information for the framework to reason about it. And because it has insufficient information, it now has to re-download and re-execute the application, right? And this re-downloading and re-executing application is what prevents us from having a quick startup performance on the client. A startup performance might be on the order of several seconds for a mobile device. So because we don't have this information, we need to re-download and re-execute. And where Qwik is different is that when an application runs on a server, we not only generate HTML, but we also serialize information about where the listeners are, where the components are, component boundaries, which component knows about which other component, what are the update rules, like when I modify this piece of code, what other component needs to get re-rendered. All of that information is packaged up in the HTML, and when it's sent to the client, and when the client wakes up, it restores all that information, and this is basically the restoring part of the magic right here. And then once everything is restored, the code can just execute where it left off, right? So in this particular case, it's very simple. You just go and assign the text to that particular piece of code, and it executes everything on from that point. In this particular case, looks like once this thing updated, the system also downloaded the framework, and so in this case, it actually re-downloaded the component right here so that the component can be re-rendered, right? So we first downloaded the code, which is the event, and then we actually had to download the component associated with this. Now, here's an interesting thing to kind of notice. The only thing we downloaded was the specific component that actually changed. There are other components on the page, but we didn't download them because we didn't need to update them. So let me show you another example. No code, right? I'm going to delete the last item. So this woke up. It restored the state of the application, which means now it had a list of to-dos. It ran a filter on it to remove the specific to-do that it wanted to have. So for example, in this particular case, we needed to recover which to-do item do you want to delete, right? So that is inside of the props of the item. So we recover the specific to-do we want to delete. And the way we do that is we iterate over all the to-dos. And if we find the item that we want to delete, we filter it out, right? And that's all we do. And then we update the items. Now, the framework at this point has to be like, okay, so you updated the items. What do I have to re-render in order to reflect this on the page? And because it has the subscription information, the framework can say like, aha, I need to download this component right here because this component has to-do items, right? So because I changed to-do items, I now have to download the component that has to-do items and execute this. And so this piece of component does its stuff to update everything. And the framework then also notices that actually I also have to download the footer. Footer is this portion right here because the number of items have changed. And again, the reason why the framework knows that is because the framework notices that you are reading items. So notice how surgical the framework is about this thing, right? Like instead of downloading all the components, I think there's about 12 components on this particular to-do app. Instead of downloading all of them at once and eagerly, the framework is very selective about what needs to download and when. And the reason for that is because we don't want to overload the browser, right? Instead of pushing all of the application to the client all at once, we instead want to pull the application as the user interacts. So if the user doesn't interact with the application, no need to download and execute any JavaScript. And as the user starts interacting with it, more and more part of it, of the app, more and more code gets downloaded. So let's leave to-dos for a second, to-do app for a second, and let's go and write some code here. So let me a second to, okay. So I'm going to modify this slightly, and I'm just going to say, I'm going to make up a new component called example, just so you get a feel for writing it. And I'm going to create a new file called example.ts. And here I'm going to export const example equals component. And it's going to return span hello world. And okay, that's ts and tsx. Then let's go back to the entry point, and I'm going to have to import this one. Oops, what happened? Import. Okay, so I did everything right. There we go. We have hello world in here. Let's just make it a little bigger. Okay, so again, hello world. No code is being downloaded in here. So let's go back into our example, and zoom in on it a little further. Oops, let's go there. Okay, so part of the magical part of Qwik is that it doesn't force you to write your code in a different way. Like the whole thing that we were aiming for is you build your apps the way you are already used to building apps, which means you build components, you create listeners, you just do the normal things that you always done, and yet somehow the right thing should happen. So let's see if we can build something very simple. But let's say we want to have a counter. So let's actually turn this to a div. And let's say we wanted to create a counter.
Misko, hi, can you hear me?
Yes, what's up?
Can you just zoom in on your screen a little bit because the code is a bit difficult to read?
How's that?
Yep, perfect, thank you.
All right. So let's do a counter. And so we have a counter over here. And again, no JavaScript is downloading. So counters are actually not very, so this so far doesn't do anything. So we probably want to store the count somewhere. So let's create a const state, store. Let's use store. And let's create an object called count. And let's start with 1, 2, 3, let's say. Oops. And so in here, we will type in store.count. And I think the thing to do here is to create a button so that we have some interaction. And we say +1. And well, I'm going to add the handler in a second. But again, oops. Oh, yes. Oh, yeah, because this is a button. Oops, where am I? I have to do a break. Okay, so now we have 1, 2, 3, and we have a plus button. And of course, nothing happens yet because I haven't done anything. So now let's create a listener on it on click. And in here, I will just say store count ++. And let's go back. And notice I have a counter that just works. Now, a couple of cool things about this is, first of all, as a developer, I didn't really have to think about lazy loading. I didn't have to think about bundling or any of these things. I just kind of wrote my code the way I would be expected to write my code, right? I have a storage where I keep my state. I render the state whenever I want, and I can do updates. Now, what happened on a client, if we can kind of zoom in, is that we created our div, right? So here's our component, here is our button. This button points to this object, which is object 1. So that, let's go here, 0, 1. So you can see here is our count, right? Here is the state of the component, which initialized to 1, 2, 3. Also, we have information about like, if this component changes, where do I have to download the template to update this particular component, right? So this update, this URL is a pointer to update this particular component. And of course, there's also subscription, and these are kind of cool things. What this says is that if, this is the 0th object, this is the 1 object. So this object right here, this is the object of index 1. So if on this object, I go and modify the count property, then that in essence invalidates hash 0. Hash means it's this ID right here. So this, as you can see, object ID of 0 is this component right here. And I know it's a component because it has a Q host. And so this is a information that basically tells the system like, hey, if I change count, I have to invalidate this component, and this component requires you to download this piece of code, which then executes, and when that executes, it will re-render 1, 2, 3 to 1, 2, 4, right? But again, as a developer, I don't have to think about any of this stuff. I've written a single file where everything got put together, and the system automatically broke everything into pieces. So how does the system know how to do that? And so that's what the $signs are for. So every time you see a $sign, it's a special hint, not just to Qwik, which there's a compiler step we call optimizer. So it's not just a hint to the optimizer, but it's also a hint to the human that a lazy loaded boundary exists. In other words, I can have a reference to an example, but the actual implementation of the example is lazy loaded, right? So I can easily let's say you have a router can say like, oh, I need to download example, so it has a reference to example. But unless example actually needs to be rendered, nothing gets downloaded to it, right? Because the example here represents only like a shell of a component that may or may not be downloaded depending on what actually happens in the application. And we know this because there's this $sign over here. The other place the $sign is on the onClick. And again, it's the same exact thing. It basically says this piece of code right here is lazy loaded only when you actually click on the component. And again, we talked about how the framework actually does this trick. It does export foo equals that. But again, you'll notice that, hey, you can't just refactor the code to pull it out the top line, is because this closes over store. And if I pull this to a top level function, the store is no longer the thing that it closes over. And so the actual extraction is a little more complicated, right? But as a developer, you just don't have to think about any of these things. So let's do another component. So let's say I have export const display, and it's going to be a component, and it's going to be super simple. All it's going to do is going to display the store dot props dot come on. Okay, so this particular thing will get props, and the props here means I'm going to take store, and the store is going to be an object that takes count. Like we could make proper types for this, but like for now I'm just kind of doing a demo here. And so instead of having a store directly here, what I'm going to do is I'm going to say display, and I'm going to pass in the store in there, right? So this store is the store. And why are you not liking? Because I put 0 in here, huh? Okay. So now it's happy, right? That script all happy. So now we took our display and we put it in a separate thing. Let's refresh this, and sure enough, our button still works. But here is something really strange that happened that you might have missed, and I think it's worth discussing. So the thing to notice is that the piece of code that we downloaded the click handler for the example onRender button, right? So this is the click handler right here that got downloaded. That makes sense because we clicked on this button. But then the system downloaded the render for the display, right? This is the display render. So it downloaded the render for this bit of code right here. And that obviously makes sense because that's the code that actually prints. But notice what the developer didn't have to do. The developer didn't have to like somehow tell the framework that this piece of code right here is never downloaded, right? So at no point, no matter what I do with my application, no matter how I interact with it, this piece of code right here is never going to be downloaded to the client. As a matter of fact, that piece of code will only execute on a server, and the client can never ever download it. And so we're in a situation where the existing frameworks require you to download everything that is visible. And so because the component is visible, you would have to download that component as well. You would have to download the example component because you needed to do a hydration on the client. But because Qwik is resumable, Qwik says, it's already rendered. I know everything I need to know about this component, and I know that there's no information that changes, and therefore I know that piece of code doesn't have to download, and therefore I'm not going to go and update it. But we can get more complicated than that. So let's say we have another button, and let's call it +A, let's say, and let's call it A's, and let's say it's 0. And here I'm going to update the A's. So let's refresh that. If I click on +A, the handler obviously executes, but because nobody is updating or nobody cares, there's no subscription on this particular property, nothing gets downloaded, right? The only thing that downloaded is the button, but because this button essentially doesn't do anything, nothing else downloads. So now I can go and say, great, so how about I will print the A's in here, and I will print store.pace. And so now I have this number and this number, right? So now if I do +1, obviously the button has to download because that's the behavior that I need. And then I also have to download the piece of code that updates the render component, right? Because I need to re-render the child component, which is right over here. So hitting +1 re-renders this component over here. But now if I hit A2, I now have to download, obviously, the button for it. But now it has to download the top level component. Let me refresh this and do it from the other end. If I click here, obviously I have to download the button. Then I have to download the render component. Oh yeah, and then the render component has a reference. These are the shells that I talked about. Let's not go too deep into it. But now I have to download the render component in here instead. So we are in the situation where as a developer, you're just building your application. You don't have to think about how the data flows or anything of that sort. And the right thing just happens automatically for you on the client, right? So the things you don't have to think about is, there's a couple of things. First of all, you don't have to think about how to create lazy loaded boundaries. And that's a big thing, because typically what happens in the frameworks is that you build up a huge app and now you deploy it and you're like, oh, crap, it's kind of slow. And so I need to, or kind of big on a mobile device. So I need to figure out a way of breaking the application down. And so now you might have to go through some lazy loading trickery in order to get it. Now, it turns out existing frameworks don't actually help you with lazy loading. Actually, I'm going to say the existing frameworks make lazy loading super hard. And the reason why they make lazy loading super hard is because lazy loading returns a promise, right? And a promise is resolved at some future point in time. So if you want to call a function, what you actually get is a promise of that function when you do lazy loading. But the framework itself is expecting the function to be available synchronously, immediately. And so because you, through lazy loading, have an asynchronous thing, but the framework expects synchronous thing, these things just don't mesh. And so the existing frameworks, while they have nothing to say about lazy loading per se, actually unintentionally make it super difficult to lazy load because existing frameworks are synchronous. The render function is synchronous, and everything about the framework is fully synchronous. And so that makes lazy loading actually hard for existing frameworks. Here, if you come to the Qwik, you didn't have to think about lazy loading at all. You didn't have to think about entry points or how do I kind of bundle it. It just naturally produced the entry points. Every time you see a $, right, an entry point got produced here, an entry point got produced here, an entry point got produced here. So if I search for the $signs on the page, I see I have 5 of them. So I have just broken my application down into 5 separate bundles. And that's something that existing frameworks just do not give you. Now, let's talk about the next part, which is the question that everybody always asks. And that question is essentially, hey, if I look at my network tab, where is that? Right here, what I am going to end up here with is a waterfall, right? So as I interact with the application, a bunch of things gets downloaded. And so I end up with a waterfall situation where the application is kind of lazy. And so if I'm on a slow network, I'm actually going to have troubles because I'm going to click on something and it's going to wait, a second or two until the code actually downloads, and there might be a cascading effect. Okay, so the way you address this particular problem is that you do prefetching. And prefetching, one of the things that the framework can do is it gives you lots and lots of symbols, lots of entry points into your application. And this information actually gets to be shipped back to the server. So the server actually knows which lazy loaded entry points are used and which entry points are not used. And it knows the information in a kind of statistical way. So it can say, like, what I see is that 99% of the people that come want this set of symbols. The next set of people want this set of symbols, and so on and so forth. And you get kind of a histogram, right? Saying like, these symbols are used all the time, and those symbols over there are not used very often at all. And that even further down, there's a set of symbols that never ever get used on a client because they never update. And so using this information, the server can actually create idealized bundle chunks. So the first bundle will contain all of the most commonly used symbols. The next bundle will contain the next set of things, and so on and so forth. And on top of that, we can do prefetching. So the moment the application loads, like I'm kind of doing a demo for you, and I kind of want to show you that everything is lazy, so I don't prefetch here. But you can imagine in the real world, you navigate to a page and you start prefetching all of the code. Now, there's a big difference between prefetching and actually executing it, right? Existing frameworks they can't prefetch the code. They actually have to fetch the code. They have to parse the code, and they have to execute the code, and then they're ready to go. Whereas in this world, you prefetch the code speculatively because you're saying, I may need it. So, I'm waiting for the user to do something anyways. So I might as well download all the code. And I'm going to download the code in the order of how likely the user actually is to do the operation. Whereas in the existing systems, there really is very little you can do. In existing apps, you're just happy you were able to break your application into 2 chunks. Whereas in Qwik, you have so many chunks that you can actually make decisions about the order in which things get downloaded. So the last point that I wanted to make a point of is that we can preload and prefetch all of these things. So even if you're on a mobile device where the application immediately loads and you download all the code and you go in a tunnel where you lose connectivity, the application is fully interactive because the app knew which of these symbols you needed and prefetched all of them. And even if you prefetch all of the application, you will still end up with less code than in the classical system, because the classical system has to download even the components that have no interaction, right? Like even the static components that aren't really interactive, those have to get downloaded as well. Whereas Qwik can just say like, actually, no, we don't need those components at all. Okay, I'm going to pause over here and ask like how we're doing on time, and should we go to questions?
You're excellent on time, and we can start questions. Yep.
All right.
Anyone has any question? Write them in the chat.
Okay, so how is Qwik different from Remix and NextJS? There's a lot of differences. So Remix and NextJS are really meant for building what I would call are primarily static sites. Think like e-commerce websites, documentation websites, where there's interactivity, but for the most part, there are clear routes between A and B and C. Like you wouldn't use Remix or NextJS. I mean, Remix maybe, but you wouldn't really use NextJS to build like an application for like your bank or something like that, because there you actually, when you navigate from route A to route B, there is state that you have to carry over, and so doing a full page refreshes between them are actually a problem. So the biggest difference is to think about it is Remix and NextJS take existing frameworks. I say existing because NextJS is tied to React and Remix kind of is tied to React, although they say that they can support other frameworks as well. They take an existing framework and they try to add to it the missing capabilities to make it server aware. And because the underlying framework has limits and basically didn't think about the server side first, there are limits to what NextJS and React can do. Now, Qwik, on the other hand, isn't trying to be what NextJS and Remix are. So in that sense, it's not a site generator, but it has a lot more area to cover because it says, I actually want to think about this problem, not just from the point of view of I'm just rendering on the client, but I want to look at it from the point of view of like, I am at a server, I will transition to the client, and therefore I want to manage the whole progress from the server moving to the client and so on. So in that sense, Qwik does a lot more than React, but doesn't do as much as something like Remix or NextJS. So Qwik will probably need a meta framework on top of it to give file-based routing and all the other things that are super popular in these other things. So Qwik is not a direct replacement for these things. And we are actually working on a project we call Qwik City, the equivalent of it. Sorry. Hope that answers the question. Do you see any value of using Qwik in hybrid mobile apps? Yeah, so I think one of the cool things that the Qwik has is that at any point in execution, you can serialize Qwik. You know, most people think about apps as, oh, you start app running on a server and then you send HTML over and then you do hydration on a client. But really what hydration does is it essentially redoes all the rendering on the client and very intelligently replaces the code without really noticing it. The thing is, if the server would send you the wrong HTML, like HTML that doesn't actually match, the client would just blow away the old HTML and then rebuild the correct one. And this actually has implication for personalization because it's difficult for server to personalize the output if the client is just going to replace it with its version of the view, right? So the client here doesn't have any concept of resumability. It's like running the application on you, and then, you know, whatever happens, happens. Qwik is different because Qwik runs on a server, it can serialize itself, ship it to a different VM, and then continue execution. But there's no reason why you can't do this again. You can save it again and then move it to a different tab. Now, moving to a different tab makes no sense. Like, it's kind of a cool party trick. But the place where it actually makes sense is for client apps. Like, if you're on the client and you're using an application for a while, and then you're quitting it or you leave, wouldn't it be nice if you could just serialize everything to something like a database or something, right? And then just quit the app, leave, and then the user comes back, and instead of showing them the default generic, you know, homepage for the app, you just deserialize where the client left off last time they were here, and then continue execution from that point on forward. And I think that's a super powerful concept and a trick that would be super useful for these kinds of applications. In which use cases do you still recommend use traditional single page applications like React and Angular? Okay, so I think the world is kind of split into an SPA and MPA world, right? Which is single page apps and multi-page apps, meaning, and if you think about what it is, the difference between the two really comes down to where is the router? Is the router on a server or is the router on a client? If the router is on a client, then you have an SPA, and if your router is on a server, you have an MPA, right? And so we have this distinction between SPAs and MPAs. And some benefits exist for MPAs and some benefits exist for SPAs. And the reason why we have this is because the frameworks don't understand the concept of the server. They just don't. Like, you either say framework, you're responsible for routing, in which case you have an SPA, or you say, or you kind of ignore the whole routing problem and give it to the server, in which case the client knows nothing about it and you have an MPA. So the cool thing about Qwik is that Qwik can move around, right? Like, it can start its life on a server and then it goes to the client, which means you can start on a server with server routing. You can start as an MPA application, go to the client, and essentially become an SPA application because you take the router with you. And that's a trick that nobody knows how to do. And it's a trick that would seriously improve the performance of the apps because the initial render will be super fast, but the subsequent renders will be super fast as well. So our goal with Qwik is to be a complete replacement for all of the existing SPAs and MPAs. So there really shouldn't be a reason why you would want to say like, oh, I want to use React versus or Angular or Vue or any of the existing frameworks instead of Qwik. The goal is that the Qwik can do everything these other frameworks can do, but on top of that, it can also understand the concept of server and clients and how to transition and serialize state and move state and all of the stuff that goes with it. So you could build full-on complex SPA applications in Qwik, or you could build MPA applications in Qwik, and nothing really changes between the two because Qwik at a fundamental level understands the server and client and moving and serialization and all of the stuff that goes between moving between a server and a client. How does Qwik handle scale and session stickiness? What do you mean by session stickiness? I think you mean that the server you need to make sure that the client talks to the same server, because the server presumably has state. The thing that I want to point out here is that when the application runs on the server, the result of running on the server can actually be fed into a CDN. So it is not the mental model that every time the application runs, a server has to execute some code. Instead, you can execute the code once on the server, or you can essentially do SSG, which is static site generation, and then take the response and put it in a CDN. And so you could be in a situation that the server only executed once, but you have 5,000 different copies of the client running at the same time. So the thing is specifically designed where there is no session between a client and a server. The best way to think about it is, again, the way virtual machines have it working. So if you've ever used a virtual machine like VirtualBox or Parallels, etc., you boot up a operating system inside of an existing host operating system, right? And at any point in time, you can save it into a file, and you can take that file and you can email it to your friends or whoever you want. You can move it onto 20 different machines, and then you can load that file and continue where it was saved, left off. So if the original time, right, you loaded the file and you open WordPerfect or whatever word processor you happen to have, and then you save it, and then you move it to a different machine and you open it, you're not going through the boot up process and opening of the application. It just comes up and the application is open and ready to just continue where you left off, right? And there is no connection between where you are and where you ended up with or something like that. So there's no session. There's no synchronization that happens in between. And this is important for scalability, because what you want, ideally, is you want to have a situation where a CDN can serve a static piece of HTML with static content and static JavaScript files. And then the client can wake up and continue running from there without having the server really be involved in anything over there. So Qwik is specifically designed with scalability in mind. The ideal case that we're going after here is e-commerce websites, right? Where you really want to come to a web page, you want it to be personalized, and I haven't talked about personalization, but Qwik has a really good personalization story. You can want the page to be personalized. You want it to be super quick at startup. The user should be able to just go and click on add to the shopping cart, and that part should prefetch and preload, so it's fully optimized. And then you can do the operation and continue execution where you left off. Is Qwik can work together with existing React, Angular, Vue, Svelte applications? Okay, so that's actually an excellent, it's almost as if I planted this question myself. So Qwik is a new framework, and because it's a new framework, it doesn't yet have any community with it. So for example, one of the problems we have is that we don't have a widget libraries that you can use out of the box. So one of the things we're working on is actually bridging them with other frameworks. Currently, we're only picking on React because the React is kind of super popular. And so one of the things we will have, and we already have prototypes of this working, is that you can take existing React component, and what we call it is we say you Qwikify it. In other words, you wrap it using some special function and you return back a Qwik equivalent component. Now, within that particular React component, you don't get all the benefits that Qwik has in terms of lazy loading and et cetera. But what the Qwik can do is that Qwik can create kind of like an island for this particular thing. And it knows that this particular component doesn't have to be hydrated until a user clicks on it or mouse moves happens or some other condition. So you can think of the Qwik as the orchestrator, and you can think of take an existing app, or we just take a existing widget library like Material UI, for example for React, and you can bring it to Qwik, and you can build Qwik applications, and you will probably have like 80% of the benefits of the Qwik. But you can reuse existing React application. And this is important because you want to be able to have a good migration story. Maybe you don't want to spend the time and rewrite all of your app in Qwik, but your app is too big and you want to be able to take advantage of lazy loading. So perhaps the top level components for your application can be in Qwik, and the rest of the components can be in React because you already wrote it in React. And Qwik will be able to break your application into islands, be able to restore the state, and a bunch of other tricks in order to get these benefits.
Misko, thank you. Oh, it's happening.
More questions?
Oh, it's not a question. I think it's just a comment, or maybe you want to say something about this?
So I really like the idea behind Qwik of registering stuff lazily. It would be awesome integrating with SolidJS with it. Ryan Carniato is awesome. We love Ryan. I chat with him almost every day. Super shy guy. Ryan Carniato is the guy behind SolidJS. We have lots of discussions about how to build bridges, how to use things together. One of the things that I actually want to point out is Qwik obviously needs to do rendering. And so we have a rendering system. And so the rendering system, we wanted to just get it up and running and do it quickly so that it wouldn't be a lot of effort on our side. So we chose kind of the React model because it's easy to implement. Something like SolidJS would actually be a much better model for Qwik. And we are in discussions with Ryan to see like if we could do something like that together. So Qwik isn't specifically tied to the rendering pipeline. The magic of Qwik isn't about the rendering. The magic of Qwik is about breaking up your application into symbols, into chunks, lazy load these symbols, storing of state, restoring of state, making the application resumable, and how it actually does the rendering is kind of an implementation detail that we could change in the future.
Cool. Thank you so much, Misko. It was really, I don't know, mind-blowing to see just the complete shift in paradigm, and I'm really excited to try Qwik and also see what happens next.
Thank you, thank you. Qwik.builder.io is the place where you can find more information on this. It is definitely a paradigm shift, and it is something that we've been kind of struggling with because when people first heard about it, they're like, oh, so it's like React or it's like Angular, it's like Vue. It's like, well, no, there's enough differences that you can't really compare it to the two. And so I think the hardest thing is explaining to people just how different it is. And this is why I'm so excited to be here and get to talk about it. And hopefully I've made a point that it is fundamentally different approach to the problem. So thank you for having me.
Yeah, definitely made the point. Thank you so much.
All right.